All right, so now let's look at the following problem. Let's classify and sketch the surface given by this equation, 4x squared minus 3y squared plus 12z squared plus 12 equals 0. So the first thing we're going to do is look at our largest coefficient here, which is 12, and we're going to divide all of our terms by that. So by 12, so now it's x squared over 3 minus y squared over 4 plus z squared plus 1 equals 0. And now we see this 1 that we have here, which we're going to subtract over to the other side. But if you look at back at our table, this 1 over here this constant term over here needs to be a positive 1. So I'm going to divide everything by a negative 1, or multiply by a negative 1. It's just going to flip all my signs. And then what you need to do is you need to look back at the table, and you're looking, notice that all your terms have squares here. And then you have 2 terms that have minus signs. So if you look back at that table, which one had all squares in it and 2 minus signs? Well, it was the hyperboloid of 2 sheets. So we've identified this surface. So now what we want to do is we want to sketch the surface. So to sketch the graph of this surface, we're going to find the traces in the coordinate planes. So we're going to start with the XY trace, XY plane. That corresponds to z equals 0. So if you plug in z equals 0 into your equation, you'll get y squared over 4 minus x squared over 3 equals 1. And what's this the equation of? It's the equation of a hyperbola. So now let's look at the xz trace. So what you're going to plug in your equation is y equals 0. You'll get negative x squared over 3 minus z squared equals 1. And if I multiply this equation by negative 1, you'll see x squared over 3 plus z squared equals negative 1. And just think about what this equation says. It says that the sum of 2 squares, this left-hand side is always positive, so there's no way that it can equal negative 1. And so we get no trace here. And then the last coordinate plane is the YZ plane. Let's get the YZ trace. That would correspond to x equals 0. So if you go back to your equation and plug in x equals 0, y squared minus 4 over 4 minus z squared over 1 equals 1. This is also a hyperbola. So we're going to kind of put these two pieces of information together to get a picture of what this graph looks like. Okay. So if I look back, what did I know? In the XY trace, the XY plane, I have parabolas. And let's see, in the Y, so let's start with the XY direction. If I look back there, I have my traces going out. Here's X, Y, and Z. So I have what looks like hyperbolas going this way. But then also in the YZ plane, I have hyperbolas as well here. So it's looking like we're getting these kinds of shapes here. So in the YZ direction, I have hyperbolas as well. So remember what kind of surface this was. We said it was a hyperboloid of two sheets, and those hyperboloid of two sheets looks like two bowls facing opposite directions, and that's what we have right here. And remember, they go out along, you look which term had the positive, it was Y, so these go along the Y-axis. These two bowls point outwards on the Y-axis.